My name is Marcel Chenier, and today I'll talk to you about how we built a radio resource management application on our NetExperience cloud, who's using TIP Open Wi-Fi open source software. As a reminder, what TIP Open Wi-Fi is from a software architecture point of view, TIP Open Wi-Fi is all about driving the WLAN architecture, hardware, software disaggregation. So the TIP Open Wi-Fi project provides a very comprehensive set of software application in open source form, first in the access points. That open source AP software is compatible with a set of access point models provided by different TIP certified access point manufacturers. From a cloud point of view, the TIP Open Wi-Fi project provides a thin layer in the cloud which we call the gateway. That software layer is responsible to terminate the control protocol from the open source AP software and present APIs northbound to cloud applications. In our case, at NetExperience, being a controller vendor, cloud controller vendor, we built a set of applications in the cloud running over the open source cloud software and the open source AP software. A bit more details about the software we wrote at NetExperience. Again, the blue part on this chart represents all the open source that the TIP Open Wi-Fi project provides, again, in the access point and in the gateway function of the cloud. We added a set of applications in the cloud, providing the WLAN controller functionality, advanced management, very detailed analytics, troubleshooting functions, automation, security, and a set of access roaming features. Again, all these different functions are implemented as microservices running on the open source cloud software. One of the issues we faced when we started to look at this architecture to do radio resource management. So the puzzling part is, given the multiple TIP Open Wi-Fi hardware vendors and each having different AP models, and those models differ quite a bit in terms of capability, in terms of power, the levels of Wi-Fi protocol it supports, how many spatial stream it supports, the form factor being indoor, outdoor, wall plate, the different antenna configuration, quite different RF front-end implementation. So the challenging part was, how can we come up with a set of radio resource management algorithms running in the cloud, but supporting all these different variants and at the same time resulting in very high and superior quality of experience for the end users. In collaboration with the TIP Open Wi-Fi project, we introduced this concept of AP capability discovery. When an AP, in this example, an AP located on floor 2, AP 08 wakes up, it will first establish a communication channel to the cloud. Specifically, that communication channel will be terminated on the cloud gateway function. That channel is used to transport telemetry information, but also to push back configuration and control to every access point in the network. Once that communication channel is enabled, the cloud gateway and the AP will exchange capabilities. The capabilities start with fairly basic hardware information, such as what is the AP vendor for that specific AP, the model, and of course the WAN MAC address, which will be used for switching routing purposes. Furthermore, the detailed radio capabilities will be exchanged. Things like the number of spatial streams, if the radio supports HT, VHT, EHT in the future, if it's using internal or external antennas, but also the detailed set of capability from a receiver and transmitter point of view for every radio band in the access point. Finally, the regulatory data will be exchanged, which is basically the set of allowed channel, power levels, DFS compliance information. For every country, this AP will operate. Once the cloud gets all this gateway information, the gateway itself will store the per AP capability in permanent store in the cloud for the different applications to use it for their own purpose. Specifically today, we want to talk about the RM, or Radio Resource Management application. So the RM application now has access to the specific capability data for each access point in the location. The first thing the RM applications will do is collect information from the location, from an RF environment point of view, from an AP point of view, radio, but also from a station metrics point of view. So the different metrics and events it will collect can cover on-channel, off-channel, physical layer metrics, MAC layer metrics, information about managed and unmanaged AP neighbors, but also things like AP 802.11 events, internal load factors, and a set of very detailed metrics for every station attached and unattached to this access point. The cloud uses an 802.11 hardware agnostic data model. So the algorithm presented in the cloud for RM used this abstraction model in combination with the AP capability database to understand the specific of every AP and relate it to the different metrics received from that AP per AP model. Once the RM application processes all this trend of metrics, the next step will be to push specific configurations to optimize the network. The configurations are pushed to every radio and every access point in regular intervals in response to trends of metrics, in response to anomaly detection. So pushing back to the network and to every radio will be things like primary and secondary channels for each band, the detailed transmit and receive cell parameters, and all of those will be customized using the AP capability database that was previously built during capability discovery. A bit more on the RM algorithm from a channel allocation point of view. Location-centric, we discussed the hardware agnostic aspect of it. The algorithm itself will build its own RF domain in addition to the knowledge of physical location the APs are deployed in. The algorithm also use a trend-based set of metrics. It will look at the past days, weeks, months of data to basically compute an estimated level of network capacity given a specific projected change in the network. So finally, once the algorithm crunches all this data, BSS data or BSS data and non-Wi-Fi data, it will produce primary and backup channels for every radios and every AP. And we made sure that every time these changes are made to every radio, there's absolutely no hit or on any client's attachment. From a radio cell coordination point of view, again, fairly similar from a location-centric and hardware agnostics point of view. The algorithms is doing capacity and coverage prediction to ensure that given a set of receive and transmit cell parameter, every single client device in the cells have access to maximum SNR and maximum data rates. The type of control we apply back to each radios are things like ERP settings, setting of the different modulation rates for the different PPPDUs, receive cell controls, like frame and mission controls and other parameters. The other aspect of radio cell coordination is a close tie to client steering to ensure that we balance the amount of clients in every cell given the new radio cell parameters. And again, the clients see no disruption during all these radio changes. And this is it in action. On the bottom left, you see the actual available spare capacity in a network. This network has 3 different vendors of access points. The algorithm fully detected the trends of metrics, detected some specific anomalies, applied new channels, applied new receive and transmit cell parameters, and as you can see on the green line, immediately delivered additional spare capacity to the whole network. So in summary, the TIP Open Wi-Fi project offers a very high quality, curated, feature-rich, community-driven, open source AP and cloud software baseline, also with a very vibrant AP hardware manufacturer ecosystem. The software architecture is fully extensible for cloud controllers, such as NetExperience, to augment with specific applications running over open source code. A good example is the NetExperience RM Cloud APNAS algorithms that were basically developed as a set of microservices with proprietary software running on open source software in the cloud. And all of this has been fully proven in the field in MDU, hospitality, education, and public Wi-Fi deployments. Thank you, and if you want to know more, please contact me, Marcel at netexperience.com. Thank you.